Welcome everyone. My name is Petra and I'm from Fontys University of Applied Sciences, and I'm going to present to you my paper, Lessons Learned from Educating AI Engineers. At Fontys University of Applied Sciences, we have bachelor level profession-oriented education, and within our software engineering education, we have a specialization called artificial intelligence, or actually ICT, information and communication technology, and artificial intelligence, to indicate that it's about the IT part of artificial intelligence. And what we do is we teach our software engineering students basic machine learning and basic deep learning, where we treat the full life cycle for machine learning projects, from data engineering to putting the machine learning system in production. And we have a system of problem-based learning. So that means that each semester the students have an actual project, a real-life project from an external stakeholder, where they have to build a machine learning solution. So in fact, we are educating AI engineers at Fontys University of Applied Sciences. The ICT and AI program consists of 8 semesters, where we have 4 semesters of software engineering, the yellow semesters, with basic software engineering and enterprise software engineering, and also including DevOps, Docker, Kubernetes, microservices, complete software engineering education. And within those, next to those 4 semesters of software engineering, they also have 2 semesters of AI, where we teach them the concepts of basic machine learning and basic deep learning with tools like Python, Keras, TensorFlow, and also Tableau and Excel. In semester 5 and semester 8, they do an assignment at a company. What we can see from our education is that we include the full life cycle. This is a picture of MLOps, or AI engineering. And you can see that the AI semesters, they cover the data and the machine learning part of the life cycle, and the software engineering semesters cover the DevOps part of the life cycle. What kind of graduation assignments, what do we educate our students for? In fact, we have some examples on this slide, but in fact, we teach them how to build software applications with a machine learning component in it. And I have to note, our students don't have a deep mathematical background, so they don't develop the machine learning model themselves, new models or new algorithms or new optimization techniques. Instead, they take existing models, libraries, and tools and implement them in a working software application. So they need to know the basic machine learning concepts and deep learning concepts to be able to do that. What did we learn from those almost 4 years now of specialization in machine learning and deep learning? We learned that there's indeed a different life cycle for machine learning projects. We use the IBM data science methodology for that. That's based on CRISP-DM. But we combine that with the software engineering life cycle and try to incorporate both in an agile way of working. We saw that it was key to teach our students a lot about data engineering, data visualization, how to communicate about data with the external stakeholders, with the customers of their projects. So it was data visualization. That's why we also include tools like Tableau and Excel to learn how to work with data, which is not standard for a software engineer. We saw, like I said before, that we can achieve valuable results for customers without this deep mathematical knowledge. So we need to teach the students how to evaluate using existing models and algorithms. And we saw that both AI engineering and MLOps, the one AI engineering being a terminology used in research, and MLOps, the one used in practice, is indeed a kind of extension of DevOps. For software engineering in practice, a lot of people use the DevOps way of working. So now for machine learning, there's the MLOps way of working, where we include data and machine learning models as first-class citizens in a DevOps approach. So what we learned in the past 4 years, that we are indeed educating applied AI engineers and that we are successful in that. So our conclusion is that we have a very nice setup because we have these real life projects in each semester. So our students learn from that, but also our teachers learn from that. We learn from it. What is the kind of problems that the companies around us are working on in the area of AI engineering? And it means we constantly have to keep track of the state of the practice in MLOps and the state of the art in research on AI engineering and see how we can combine this in an improved education for our students. But at the same time, we're also educating the companies around us because we see that also there, this transition from software engineer to AI engineer needs to be made and they need help doing that. So this is a challenge for education as well. If you're interested in working with us in this kind of dynamic environment, please contact me at my email address. Thank you very much for your attention.
Okay, we are live with Petra. This was the last paper presentation, last but not the least. So there are a few questions for you, Petra. And one comes from Ivica, who says, thanks for the presentation. Do you teach machine learning basics, like principles of algorithms in the course, or do you assume the students have this knowledge?
Actually, if you look at it, it's not just one course. It's a whole 4-year bachelor practice-oriented education. So that means we have one full semester of basic machine learning. The principles of algorithms, the simple algorithms like regression and decision tree and support vector machines, and one semester of deep learning where we go into the different types of deep learning algorithms and natural language processing, and then actually 3 semesters of software engineering techniques and principles like microservices, Docker, Kubernetes, system enterprise architectures, and stuff like that.
Okay, very good. So another question from Luis. Nice work. As we have seen in previous talks, education is quite important when it comes to helping organizations follow software engineering best practices in AI development. Do you plan to do some sort of assessment to check whether your students are actually able to bring new practices to the industry setting, or the learning curve of the whole ML realm is so steep that we are a bit far from that?
So we see it the other way around. So all of our students, they do their bachelor thesis in industry. So industry comes to us with bachelor thesis projects where they ask for this new machine learning or AI knowledge from our software engineering students. So we are doing it by supervising the students the best we can in the industry project. So it's a one-on-one collaboration between a thesis supervisor and an industry supervisor. But what we plan to do, of course, because this is quite new, we plan to come to a kind of longer term collaboration. That's what I also said in my presentation. I would like to have longer term collaborations to really learn together over several bachelor theses what works well and what doesn't work well. And also, like I do in my blog post, publish about these findings that we can learn from the bachelor thesis of our students.
Okay, great. So in 15 seconds, one question, last question from Silverio. Great presentation working on education. What type of real projects and local companies do students conduct? In which application domains?
I think that's a nice presentation to take to the discussion room, or a nice question